Good morning, grade nines. I hope you are well today, and I'm happy to be back here with you. I know we've been having some bit of problems, but those of you who were able to join me last week, I am still grateful for that. So today, grade nines, we are doing natural sciences. I'm still your host, Olisani Mbata, and you can find me on Twitter at MbataX or at Instagram at XKIM. And I hope I've been able to assist everybody who has touched base there. So today's lesson, in today's lesson, we will be looking at, we're gonna look at the following. Our network is a bit slow, but it's going to be fine. Don't despair, we'll be fine. By the end of this lesson, you all know that during term 2, we are doing matter and materials. So by the end of this lesson, you will learn the following: reactions of acids with metal oxides and metal hydroxide. We'll also look at how acids actually react with metal oxides. We'll also look at acids and metal hydroxides. How are hydroxides formed, and how can hydroxides neutralize acid? We'll also look at skills. So the focus skill for today is asking a testable question. As a science learner, you should be able to ask a testable question. I will also take you through that. Before we can continue with a lot of things, grade 9s, I want us to first look at the question, the corrections of our homework. Remember, I had given you a homework last week. So we are doing corrections now. Are we clear on that one, grade 9s? So number one says, acids have a relatively high pH compared to water. Is the statement true or false? Acids have a relatively high pH compared to water. Is this statement true or false? Acids really has a relatively high pH. True or false? So the statement is false. We are experiencing a bit of a delay with our network, grade 9s. Please bear with me. So the correct answer there, acids do have a relatively high pH. So no, they do not have compared to water. What is a water pH? A still water will have your pH of what color? They will have a pH of 7, I'm sorry, a neutral water. It's neutral. Water is neutral. So the correct answer there will be false. Which of the following pH values would be acidic? Is it 2? Is it 7? Is it 9? Is it 14? The correct answer is 2. That will be acidic. Are often slippery substances that are used for cleaning. What are we talking about? Are we talking about solution, solvent, bases, or acids? So it's definitely not solvents, it's not solution, it's not acid, it is base. We are doing corrections from our previous lesson last week, Friday. Are we clear, grade 9? Let us look at these first 3 questions. Acids have a relatively high pH compared to water. True or false? I said that is false. Remember from our pH scale that we did last week, acid from 0 to 6. Then at 7, we said it's neutral. And then 8 to 14, we said it's basic, so or alkaline. Then which of the following pH values would be acidic? 2, 7, 9, 14. I said the correct answer is 2, because when you're looking at the pH scale, you're looking from 1 to 6. Those will be your acidic, and the strong acids are from 0 to 3. Then what are often slippery substances that are used for cleaning? I even made an example last week that ammonia, we use it for cleaning and we call it handy Andy. I also showed you baking powder last week. That is also a base. So even if you touch a baking powder, you will feel it is a bit slippery. So those are our bases. Né? Let us continue with our corrections. Number 4 says bases taste bitter while acids taste sour. Is this true or false? This is true. Why is it true? Remember that when we were given examples of acids, you saw a vinegar there, so it is a bit sour vinegar. And then when you taste Colgate, it will be bitter. It's not as strong as acid. What is the scale called that measures the strength of acids and bases? Is it a pH scale? Is it acidity scale? Or is it a corrosive scale? The correct answer is a pH scale. It is a pH scale. So when we want to check how acidic or basic is a substance, we use a pH scale. Which of these is a proton donor? Is it a buffer? Is it a base? Is it a water molecule? Is it an acid? The correct answer is a buffer. So a buffer is almost as a neutralizer. So it donates it donates protons. I will actually explain further with what is a buffer as we continue with our today's lesson, grade 9. So bases taste bitter while acids taste sour. Then you have, what is the scale called that measures the strength of acids and bases? It is called a pH scale. Which of these is a proton donor? A proton donor is a buffer. Grade 9, before we continue, if you feel I'm moving too fast, please raise your hand and I will slow a bit down. Let us continue to number 7, grade 9s. Which pH value indicates a neutral solution? Is it 0? Is it 5? Is it 7? Is it 10? Which pH value indicates a neutral solution? So I've explained that from our pH scale, grade 9, 0 to 6 is acidic. Then from 8 to 14, it's alkaline or a base. So those are bases. Then now 7 will be your neutral. 7 will be your neutral. Are we clear, grade 9s? So on the pH value, if something is on a pH scale, if something is on 7, then that thing we say it is neutral. An example of a base is ammonia. In fact, most household cleaners are based. If you can remember, I just explained this. Is this statement true or false? It is definitely true. Most of our household cleaning material are basic. You cannot, even an oven cleaner is a base. What is the pH of pure water? What is the pH of pure water? Number 9. The pH of pure water is 7. The answer is 7. So I did say that it's not neutral, it's not alkaline, it's not acidic, but it is neutral. Therefore, it will be 7. Let us continue. Grade 9s, you already know that a pH, which pH value indicates a neutral solution? It's 7. When you're looking at at your pH scale, and then any substance is on 7, and then you know it is neutral, meaning it is not acidic or it is not basic. An example of base is ammonia, and in fact, most household cleaners are bases. True. What is the pH of pure water? I said it is 7. So that means pure water is not acidic or is not basic. It is just neutral. Let us continue, grade 9s. Number 10, they say you suspect that a chemical that you are testing in the lab is strongly acidic. What might be its pH? Is it 2? Is it 6? Is it 7? Is it 13? So if you suspect that a substance that you're using or working or testing in the lab is acidic, its pH will be 2. I've been explaining this grade 9. I said if you are looking at your pH scale and then from 0 to 6, that will be acidic. And then 7 is neutral, 8 to 14. So that means our scale ranges from 0 to 14. Are we clear, grade 9s? Thank you very much. What is produced when an acid reacts with a base? We did this on Friday. When an acid reacts with a base, what do we get? We get water and salt. We're gonna do this now again. For those of you who could not join us last week, we're going to do a recap on this during this lesson. How nice is that? Mr. Mbata cares. So grade 9s, now when we're looking at what is produced when an acid reacts with a base, look at that. We said water and salt. So the type of water and the type of salt, grade 9s, it will depend on what you call on the reactants. Remember when we were doing the reactants and the products? So now whatever the product obviously is determined by your reactants. Grade 9s, are you following? Thank you very, very much. Let us move to our number last in corrections. Where is our number 11? Oh, I've done number 11. So we are done with our we are done with our corrections, grade 9s. Are we clear on that one? Yes. Please, if you did not understand anything, don't hesitate to contact me on Twitter or on Instagram. I will be very, very much happy to assist. Then let us look at today's lesson, reactions of acids with metal oxides and metal hydroxide. What is a metal hydroxide, grade 9s? A metal hydroxide is a compound consisting of a metal and a hydroxide. For example, magnesium is Mg from our periodic table, and then hydroxide is represented by OH. Are we clear? Can be formed when a metal oxide reacts with water. So a metal hydroxide can be formed when a metal oxide reacts with water. Remember what is a metal oxide from our first lesson in chemistry? We said a metal oxide is the reaction between oxygen and a metal, regardless of what metal. Whenever any metal, when it is reacting with oxygen, the product is always a metal oxide. So we've got acids and metal oxides that we will be looking at now. Acids and metal oxides. Metal oxides tend to react as base. So that means its pH now is between 8 and 14. Remember from our pH scale, you already know where the bases are arranged. All right. Thank you very much. They have the ability to make acid less acidic. That's why metal oxide can react with acids. Why? To reduce the acid pH to actually make it less acidic. So if something is less acidic, it will be around 5, 6 or 4, 5, 6, right? Remember that I gave you the example last week. I said the pH of milk is 6. That means it is less acidic. It is less acidic. Are we clear? Then we've explained this, that acid reacting with metal oxide, we get salt and water. Acid reacting with metal oxide, we get salt and water. Let me repeat this slide, grade 9, so that you understand. I might be moving too fast, so I don't want to. Metal hydroxides are formed when a metal oxide reacts with water. So a metal oxide reacts with water to get a metal hydroxide. So we've got magnesium hydroxide. If you're looking at this, you would see this is a metal hydroxide. Why is it a metal hydroxide? Because magnesium is a metal. From our periodic table, we already know that. So then when we have acids reacting with a metal oxide, then we get our product is always salt and water. It is always salt and water. Are we clear, grade 9? So we're gonna look at few reactions now to actually to see how is salt and water formed when a metal oxide reacts with acid. Are we clear, grade 9? So they say the type of salt that forms depends on the acid and a metal oxide that is used in the reaction. Are we clear, grade 9? A metal oxide reacts with acid to give us a certain salt plus water. How so? They say the type of salt that forms depends on the acid and metal oxide that is used in the reaction. Word equation, WE stands for word equation, grade 9. So your examiner sometimes will say to you, write the word equation of the following reaction, and then the reaction will be presented with symbols. Then WE stands for word equation. SE stands for symbol equation. Are we clear, grade 9s? So our word equation says magnesium oxide reacts. In physics, we don't say plus, but we say reacts. That positive sign there, or that addition sign, stands for reacts. So magnesium oxide, which is a metal oxide, reacts with hydrochloric acid to give us magnesium chloride and water. Are we clear, grade 9? Magnesium oxide reacts with hydrochloric acid to give us magnesium chloride and water. Those are the reactants. The reactants are magnesium oxides and hydrochloric acid. And then the products are magnesium chloride, which is a salt, plus water. Then the symbol equation is magnesium oxide reacting with hydrochloric acid to give us magnesium chloride plus water, and water. This equation is not balanced. Remember, I told you it is very, very important to balance your equation at all times. It is important for you to balance your equation at all times. So now the symbol equation that is following is now balanced. Magnesium oxide and hydrochloric acid, and then our product will be magnesium chloride plus water. Then we've got 2 hydrogens on the left and 2 hydrogens on the right, on the left and on the right. We've got 2 chlorine, and then we've got 2 chlorine, and then we've got magnesium, and 1 on the right and 1 on the left. We've got oxygen, 1 on the left and 1 on the right. Therefore, everything is balancing. Remember to balance your equation at all times, grade 9s. Please, please, please. You write it as a word equation, you turn it to symbol equation, and then you check if it is balanced. I hope you are following grade 9s. I hope you are following grade 9s. Let us look at this one again. Calcium oxide, which is a metal oxide, is reacting with sulfuric acid. And then we get calcium sulfate, which is a salt, plus water. So those will be our products. Let us look at the simple equation. Calcium oxide and sulfuric acid, then we're getting calcium sulfate and water. It is balanced. It is balanced, grade 9. So you don't have to balance it again. It is balanced. The reactants are equals the products, grade 9. Whatever is on the left, we call it reactants. Whatever is on the right, we call it products. Are we clear, grade 9? So whenever calcium oxide reacts with sulfuric acid, the products are equals or they balance with the reactants. Let us look at another example, grade 9. Sodium oxide reacts with nitric acid. So nitric acid reacts with the sodium oxide. So sodium oxide is a metal oxide again. Sodium is a metal, is reacting with oxygen, and then we get a metal oxide. There is sodium oxide N2O plus HNO3 reacting with HNO3, which is a nitric acid, and then we get NaNO3, which is sodium nitrate and water. So sodium nitrate is a type of a salt, but the equation is not balanced. It is not balanced. Let us balance it here. Let me show you how we're balancing it. So on the left, we have 1, 3. That means we've got 4 oxygens. Then we come to the left. We have, let's just look at the unbalanced one, grade 9s. Let us count the oxygens first. It's 1 and 3. So that means it's 4 on the left. Let us go in on the right. It's still 4, 3 and 4. So the oxygens are balancing. What is it that is not balancing? Hydrogen, on the left we have 1, and then on the right we have 2. So already we say this is not balancing. So we need to balance our hydrogens first so that they are 2, 2. Then we put a 2 here. This 2 here. Then this 2 is here to balance our hydrogens. By putting that 2 there, everything you can see, it is not yet balancing. Our sodiums are not balancing now. Are we clear? Why are they not balancing now? Because this side it was 1, and this side we had 2. So we put this 2 again here. And our sodiums are balancing. And then so our nitrogens as well, now they are balancing. Are we clear, grade 9? Are we clear? You count each and every element. You count each and every element, grade 9s, so that you can be able to balance everything. You don't look at it and then assume. You need to count how many sodiums do I have on the left? How many do I have on the right? How many oxygens do I have on the left? How many do I have on the right? How many hydrogens, so on and so forth. And then you will see that, oh, my equation is now balanced. Are we clear, grade 9s? Are we clear, grade 9s? You can take notes on that, or you can actually find these notes on YouTube, or you can find these notes on our site, www.africateamgeeks.co.za. Then you can actually download the notes there via the grade 9 Natural Sciences link. Let us continue. Acid and metal hydroxides, formation of hydroxides. When metal reacts with water, they tend to form a metal hydroxide. So when metal reacts with water, then they tend to form a metal hydroxide. A hydroxide ion consists of an oxygen atom and a hydrogen atom. They are held together by a bond. So you will know more about polar bonds and covalent bonds and all sorts of bonds later in the year or next year. The ion carries a negative electric charge and has a chemical formula OH. OH. That's how this is how we represent a hydroxide. This is the symbol for hydroxide. So if you're saying sulfur, you're saying, let's say, what hydroxide? Calcium hydroxide, it will be CaOH. It will be CaOH. Then we all know that is a calcium hydroxide. So this is a hydroxide. This is a symbol for hydroxide. Metal hydroxides are bases. So now we already know that their pH is from 8 to 14. Metal hydroxides, the solution 10 red litmus blue. So if you are working with a litmus paper and then you put it in a hydroxide, the litmus paper will be blue. Hydroxide can neutralize acids. Metal hydroxides have the ability to make an acid less acidic. We've already spoke about this grade 9. I said then a hydroxide is a base. Therefore, when it's reacting with acid, it will make an acid to be less acidic. When an acid reacts with metal, a hydroxide, salt and water forms. The type of salt that forms depends on the acid and metal hydroxide that is used in the reaction. Let us look at the example when a metal hydroxide reacts with acid and the water and salt is formed. Word equation, we've got sodium hydroxide reacting with hydrochloric acid, and then we get sodium chloride. Sodium chloride is your daily salt. So, and water. Sodium, then the equation is balanced. So it's easy for me to explain this to you. In this instance, we can count the elements very, very well here. You see, sodium is 1, Na, it's a symbol for sodium. It's 1 on the left, and then you're coming on the right, and it's still 1. Let's count the oxygen. Oxygen is 1 here on the left, and it's also 1 here on the right. Then a hydrogen, you've got this hydrogen from sodium hydroxide and this hydrogen from hydrochloric acid, and then there are 2 on the left. And then we still get 2 on the right. There's H2 from that water compound. Can you see that? And then chlorine, it's 1, 1. You see why I'm saying this equation is balanced? Thank you, grade 9. I think this was a very, very perfect example for you to follow as to how we balance the equations. Can you see that, grade 9? I want you to write this down. Metal hydroxide reacts with acid, you're getting salt and water. Then with equation, sodium hydroxide reacts with hydrochloric acid to give us sodium chloride and water. Therefore, the balanced equation, the symbol equation, that is sodium hydroxide and hydrochloric acid. Therefore, we're getting sodium chloride and water. Can you see why are we saying it is balanced? You're looking at the arrow here, and then you say, I'm going to count the hydrogens on the right from the product. How many hydrogens do we have on the right? We have 2 hydrogens from that water compound, which is H2. And then how many hydrogens do we have on the left? It's 1 from the hydrochloric acid and 1 from sodium hydroxide. And then we've got 2 on the left as well. Therefore, they are balancing. Can you see? We've got 1 oxygen atom on the left and we've got 1 on the right. Therefore, they are balancing. Looking at chlorine, 1 on the right and 1 on the left. Therefore, they are balancing. Are we clear? 1 sodium, 1 sodium. Therefore, they are balancing. So I want you to know how to balance the equations, grade 9. Then Let us look at another one. Potassium hydroxide. Potassium hydroxide, it reacts with sulfuric acid, which is H2SO4. Then we're getting potassium sulfate and water. Then the first simple equation, it is not balanced. Potassium hydroxide reacts with sulfuric acid to give us potassium sulfate and water. And then you can count and you will see that hydrogen atoms and potassiums were not balancing in this equation, the first simple equation. I even wrote unbalanced. Then I balanced it on the second one. Can you see how we did it, grade 9? Can you count the elements? Can you count the elements, grade 9, to see how we did it? This one is not balanced because if you're looking at the very first potassium molecule here, you would see that we've got one potassium on the left, but when we're coming to the right, we already have two. Therefore, that's why I put this two here to say I'm balancing the equation now. I'm balancing the equation. If we've got two potassium on the left, we must have two potassium on the right. Is everything balancing? No. Let us count how many hydrogens do we have on the left? On the left, we've got 1 and 2, which is 3. On the left, we only have 2. Are we clear? Then now, with me putting this 2 here, we're gonna have 4, because this 2 represents the entire compound, potassium hydroxide. So that means we've got 2 potassiums, 2 oxygens, and 2 hydrogens. Therefore, this side, if we've got 2, we put this 2 here to say, okay, we're balancing our hydrogens. How many hydrogens do we have on the left? We have 2 and 4. And then if we put the 2 here, 2 by 2, it's going to be 4. That means our hydrogens are now balancing, our potassiums are now balancing, and our sulfates are now balancing. Are we clear, grade 9? That's how we balance. We count one by one, and we need to make sure that they are balancing at all times. Are we clear, grade 9? Please make sure that you know how to balance the equation. If you do not understand, by the end of this session, you can actually follow me on my social medias and inbox me, direct message me. I will assist you as to how we're balancing the equations. Let us look at another metal hydroxide. Magnesium hydroxide reacts with nitric acids and magnesium nitrate is formed and water. So unbalanced one, there it is. Again, magnesium hydroxide and nitric acid, then we're getting magnesium nitrate and water. Then look at the second one. I'm now this one is now balanced. Can you see? We are balancing it. How we balanced it, grade 9. Can you see? That's how we balance it. And we now know the reactions. We know when a metal reacts with oxygen, we get a metal oxide. When a non-metal reacts with oxygen, we get non-metal oxides. And then we also have now when a metal hydroxide reacting with acid, the product is always a salt and water. We already know that. Are we clear, grade 9? We already know that. So I want you to take notes. You need to know what certain elements will give us when they react. So I told you that we'll also do a skills focus. So ask a testable question. As a science learner, you need to ask a testable question. How do you ask a testable question, grade 9? Or what is a testable question? A testable question is the question you are trying to answer through your investigation. So when you are going to go to the lab, you cannot just wake up and say, I'm going to the lab. So if we're going to go and let's say we're going to test elements, we will say, I want to know if metals are acidic. And then you'll go to the lab, and then now that's a testable question. Are metals acidic or basic? And then you can investigate that in the lab. It is important to word your question in such a way that you can answer it by conducting an experiment or a test. Metals, so you're not going to say is calcium acidic. You need to make your question to be broad enough so that you can actually collect data in finding an answer. How to write a testable question? Ask questions. Make a list of questions about something you have noticed or observed. Here are some examples of how your question could start. Why does metal hydroxide make acid less acidic? I wonder how water and acid react. I wonder how water and acid react when you are actually now asking some testable questions. What would happen if base reacted with acid? What would happen if base reacted with acid? Is it possible for acid to react with a base? How long is the reaction of an acid and a base? Are we clear? How long is an acid of a base? How long is the reaction of acid and a base? Are we clear? So we need to actually ask those testable questions. So you also need to choose one question. Choose one question that you would like to investigate further. Think about what type of experiment or test you will need to conduct to answer your question. Think about what type of experiment or test you will need to conduct to answer your question. Make sure your question is testable, grade 9. All the time, make sure that your question is testable. Are we clear, grade 9s? Are we clear?
Yes.
A question is testable if you can answer it by collecting evidence through a test or experiment. It is possible to carry out a fair test that will answer it. It is a specific question that has only one answer, not a general question that has many answers. Are we clear? It shouldn't have many answers. It shouldn't have many answers. Can actually be between the elements or between the compounds. What do we get if we react water and acid? If you say H2O reacts with hydrochloric acid, is that test even possible? Those are the questions you need to ask yourself as a science learner. So I want you to write this homework down. I'm giving you 2 minutes to copy this homework down. Sodium hydroxide reacts with nitric acid. What are we getting? Calcium hydroxide and hydrochloric acid. What are we getting? Magnesium hydroxide, MgO2, and sulfuric acid. Potassium hydroxide and hydrochloric acid. Aluminum hydroxide and hydrochloric acid. So these are metal hydroxides reacting with acids. What do we get? What do we get? What do we get? Yeah, grade 9s. I want you to write this. So you first are given a word equation. Therefore, you need to write now a symbol equation. After writing a symbol equation, you need to balance that symbol equation. So number 1 is 3 marks. Number 2 is 3 marks. All of them, there will be 3 marks, 3 marks, 3 marks. Why are they 3 marks? Because you're going to first have a word equation. So you say sodium hydroxide reacting with nitric acid. So you'll say sodium hydroxide, positive sign or addition sign, and nitric acid, you write an arrow there to give us an answer. Remember, when you're writing this reaction, grade 9s, I should remind you this. You do not write an equal sign, but you write an arrow as I've been showing you. Are we clear on that one, grade 9? You write that. Please, 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 please make sure you do this homework. We will do corrections first thing tomorrow. It's only 5 equations that you need to do. Then we will be continuing with our tomorrow's lesson. I'm hoping you are done, or you can go on YouTube and get this video. It will be available immediately after this lesson. You just type the African Team Gigs and then grade 9 Natural Sciences. Our video will be there. And then remember, let us recap on this one. These are metals reacting with oxygens to give us metal oxides. They're giving us metal oxides, not metal hydroxides, but metal oxides. So now if you've got aluminum and oxygen, lead and oxygen, beryllium and oxygen, mercury and oxygen, and potassium and oxygen, what do we get? What do we get? Complete the following chemical equations and then balance them. So I've done them for you. I've actually balanced them for you. I want you to actually look at them and see how we did it. I want you to go through these equations. I've completed them for you and balanced them for you. I want you to see how we did it. I want you to see how it is done. Are we clear, grade 9s? Are we clear on that one?
Yes, sir.
Yeah.
Let us look at this homework. Let us look at this other homework. We've done it before, but I want you to actually understand it even further. If we're getting a metal reacting with oxygen, what do we get? We get a metal oxide. If a non-metal reacts with what to give us non-metal oxide? When non-metal reacts with oxygen. Write a balanced symbol equation for each of the following reactions. Carbon burns in oxygen, magnesium burns in oxygen, sulfur burns in oxygen. Define the term rusting. Remember when we were doing this? Do you remember when we were doing this, grade 9s? We will do it again tomorrow as part of our corrections, but don't forget the fundamentals, the fundamentals, the building blocks of chemistry as we are moving towards the more complex stuff. You need to always remember this so that you can understand the complex stuff. So you've got 2 homeworks, grade 9. You've got this one and the one that of our today's lesson. This one. I'm going back to the slide of the today's lesson. This one. Please, 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 grade 9, do these homeworks, both of them. Then tomorrow we will be doing our corrections. And then we will move on to our tomorrow's lesson. We'll be focusing on, please join us on the next lesson, reactions of acids with metal carbonates. With metal carbonates. We're doing with metal hydroxides today. Tomorrow it will be acid reacting with metal carbonates. We'll also get to understand what are metal carbonates, and then applications of acid-base reactions and skills focus, how to write a summary, and then again, reactions of acids with metals. Please, please bring questions if you've got any tomorrow. I thank you so very much. We've been great. Thank you so much.
Bye, sir.
Bye.
Nice knowing you.
Bye, sir.
Bye, sir.
Bye bye.